Welcome back, everyone. So last time we covered the foundations, layers 0 and 1 of the blockchain stack.
Right, the bedrock infrastructure and the main blockchains themselves.
Exactly. Today, we're moving up layers 2, 3, and 4. The mission is to see how these layers make blockchain, actually work better for you. More scale, more usability.
Yeah, this is where things really start to connect with practical use cases. It gets much more tangible.
Okay, let's kick off with layer 2. We know layer 1s, like Bitcoin or Ethereum, can sometimes get slow or expensive. How does layer 2 help fix that?
Well, layer 2 solutions essentially build on top of layer 1. Think of it like adding extra lanes to a highway.
Yeah.
They handle a lot of the transaction traffic off the main chain, off layer 1, and then just report back a summary.
Uh-huh. So it speeds things up and cuts down costs.
Precisely. Less congestion on the main layer means faster processing and lower fees, generally speaking.
And we hear about things like roll-ups on Ethereum. How do they fit in?
Rollups are a big part of layer 2 on Ethereum, yeah.
Mhm.
They bundle or roll up hundreds, even thousands of transactions into one single piece of data.
One piece.
Well, one compressed batch that gets submitted back to layer 1, it's super efficient.
Are there different kinds? I think I've heard optimistic and Zik.
That's right. Optimistic rollups think optimism, arbitrum. They work on an innocent until proven guilty basis. They assume transactions are valid unless challenged.
Okay.
Zik rollups like ZK Sync or Starknet use complex math, zero-knowledge proofs to mathematically prove the validity of the whole batch up front. Different tech, different trade-offs.
Interesting. And Bitcoin has layer 2 as well, the Lightning Network.
Absolutely. Lightning is a prime example of another layer 2 type called state channels.
State channels.
Yeah.
How do they work?
Imagine you and I want to send small payments back and forth. We open a direct channel between us off the main Bitcoin chain. We can transact instantly, almost for free, as many times as we want within that channel. Only opening and closing the channel actually gets recorded on layer 1.
So that's great for things like micropayments.
Perfect for it.
Yeah.
It makes Bitcoin much more practical for small, everyday transactions. So layer 2 is really key for scalability.
Got it. It increases the throughput, lowers the fees. But you mentioned trade-offs.
Well, yeah.
Yeah.
While they boost efficiency, some layer 2s might be a bit more centralized than layer 1 just because they're newer or smaller networks. And crucially, their ultimate security still relies on the underlying layer 1.
Right. They inherit security from the base layer. Makes sense. Okay, let's climb up to layer 3, the application layer.
Exactly. Layer 3 is where decentralized applications, or DApps, live. This is where most users actually interact with blockchain tech, even if they don't realize it sometimes.
So these are built using smart contracts.
Correct. Smart contracts running either directly on layer 1 or, increasingly, on those faster layer 2 networks we just discussed.
Can you give us some examples? What kind of dApps are out there?
Oh, tons. You've got decentralized exchanges, DAXs like Uniswap for swapping tokens directly. Then DeFi lending platforms like Abo, where you can borrow or lend crypto.
Right. DeFi is huge.
And things like NFT marketplaces. OpenSea is probably the best known one for buying and selling digital collectibles. All layer 3 applications.
So layer 3 is really about taking the core blockchain capability and building actual usable services on top.
Precisely. It abstracts away a lot of the lower level complexity, but keeps the benefits like transparency and user control.
Okay, apps are great, but how do people use them easily? That brings us to layer 4, right? The user interface layer.
You got it. Layer 4 is all about accessibility. It's the collection of tools and interfaces that let regular non-technical people engage with everything underneath.
Without it, it would be pretty tough going.
Extremely difficult, yeah. Layer 4 is critical for adoption.
So what kind of things are we talking about in layer 4?
Well, the most obvious one is wallets. Things like MetaMask or maybe the Coinbase wallet. They let you store your crypto and connect to DApps.
Essential. What else?
You also have things like API services, and Fura is a big one, that help developers easily connect their apps to the blockchain network. Then there are user dashboards for tracking your assets or your activity in a specific D. And block explorers like Etherscan for Ethereum.
Ah, the tools that let you actually see the transactions on the chain.
Exactly. They provide transparency. Anyone can look up transaction details. All these layer 4 components work together to make the whole ecosystem usable.
So layer 4 is basically the gateway for most users, the friendly face on the complex tech.
That's a great way to put it. It's the bridge connecting everyday users to the power of layers 1, 2, and 3.
Okay, so let's quickly recap. Layer 2 adds speed and efficiency on top of layer 1. Layer 3 gives us the actual applications, the dApps. And layer 4 provides the wallets and interfaces to make it all accessible for you.
Yeah, that sums it up nicely. Each layer builds on the one below it, creating this increasingly functional and user-friendly stack.
It really shows how the space is maturing, moving beyond just the core tech. So here's something to think about. As these layers keep getting better and working together more smoothly, what completely new uses for blockchain might start showing up in our daily lives? Things we haven't even thought of yet.
That's the exciting question, isn't it? The potential is still unfolding.
Definitely something to ponder. Thanks for joining us on this deep dive. We'll catch you next time.